So next we will discuss about the complex numbers array. Okay, so last class we have seen how to create a complex number. So today we will discuss how we can form a complex number array. Okay, array of complex numbers. Okay, now let us see one example. So here I have defined my A and B. What is my A and B? Just a column vector. How it will be a column vector? What do you mean by column vector? Column vector will be having one column and only one column and different rows. Okay, that is a column vector. What do you mean by a row vector? Row vector means you will be having only one row, different columns. Okay, what do you mean by column vector? Column vector, different rows, but only one column. That is column vector. One column, different rows. Okay, so here this A is a column vector because this 1, 2, 3, and 4, these are the elements of the column vector. Isn't it? These are the elements 1, 2, 3, and 4 are the elements of the column vector. Okay, here I am separating one separated by this semicolon. Okay, 1 is separated by semicolon, then 2, then again a semicolon, then 3, again a semicolon, then 4. Let me change the font size. Okay, here you can see you are separating it using semicolon. That means 1 is the first row, second row will be 2, the third row will be 3, fourth row will be 4. That is the meaning. And again, you are defining another variable B, 2, 2, 7, 7. Just I am defining two column vectors. 2 is the first row, second row will be 2, third row will be 7, fourth row will be 7. Like that. Next, I am creating Z. What is Z? It's a complex number. So I need to use how can you create a complex number? You can create a complex number by using the keyword complex. So complex of A comma B. What is A? A will be my real part, and what is my B? B will be my imaginary part. So these are two separate arrays. A and B are two separate arrays. And from these two separate arrays, I am creating a complex number. Okay, so with A as my real part and B as my imaginary part. So how will the complex number look like? A part will be this A numbers or the elements inside A array will be my real part, and the elements inside the B array will be my imaginary part. Okay, so let me display this Z. What is my Z? The complex array. So let me run this particular code. So just type Z. Z is my complex array. So you can see your Z. This is an array of complex numbers. See 1 plus 2y. First of all, I will show you what is A and what is B. What is A? A is 1, 2, 3, 4. This is a column vector, only one column. What is B? Second column vector, 2, 2, 7, 7, as you have already defined. 2, 2, 7, 7. Next, what is my Z? Z is my complex. This real part is 1, 2, 3, and 4. This is the real part. What is the imaginary part? 2, 2, 7, and 7. So 1, 2, 3, 4, they are from A, and 2, 2, 7, 7, they are from B. Okay, so A is my real part and B is my imaginary part. So this is how I can create a complex number Z from two different arrays. Okay, now how can you find the sum of a matrix? So if I am entering a matrix like this, suppose in a command window, so this is in a command window, suppose I am taking my, suppose S is equal to 1, 2, then 3 and 4. Okay, 1, 2, 3 and 4. This is a matrix. 1, 2 is the first row, 3 and 4 is the second row. And if I type 1, 2, this time taking is an array. 1, 2, 3, 4. Okay, let me put S is equal to 1, 2, 3, 4 is an array. Okay, now I am summing all the elements. Sum of S. Sum is a keyword or a built-in function in order to find the sum of all the elements in the array, sum of S, that will give you 10. The sum of all the elements, 4 plus 3 plus 2 plus 1, that will be 7. Sorry, 4 plus 3 plus 2 plus 1, that will be 10. So the answer will be 10. That is the importance of the function sum. If you want to find the sum of the elements in a particular array. Suppose it is a matrix. S is equal to 1, 2, 3 and 4. This is a matrix. See, this is a matrix. S is a matrix. And if you want to find the sum of this particular matrix, sum of S. What is the sum of S? Sum of S, for a matrix, the function sum will give you the sum of the elements of the columns. So first column, what is the first column? 1 and 3. 1 and 3 is the first column. So what is the sum? 4 will be the sum. So 4 will be the sum. Okay. Now, what is the second column? 2 and 4. 4 plus 2, 6. 6 will be the sum. So sum function of a matrix will give you the sum of the columns. Will give you sum of each column. So 4 and 6. 4 is the sum of the first column. Then 6 is the sum of the second column. If you want to find out the sum of the entire elements of the matrix, then again you need to take the sum of sum, isn't it? So again, sum of S will give you sum of columns because S is a matrix. Now again you need to take the sum of S. Okay, so this will be the sum of the columns. Again, if you take the summation, sum, then it will produce the summation of the entire matrix or sum of all the elements of the matrix. Okay, the answer will be 10. You can check with the answer. 4 plus 3, 7, 7 plus 2, 9, 9 plus 1, 10. Okay, so the answer is correct. So sum of S will give you all the sum of all the elements of the matrix. Yes. I hope this is clear. With that, we will proceed. Okay, now Z is a complex number or a complex array. Okay, now this is Z. If I execute this Z, what will be my Z? My Z is, this is a column vector. This is only an array, not a matrix, isn't it? This is only an array. This is a column vector. 1, 2, 3, 4. 4 rows and 1 column. So this is an array, not a matrix. So you can just put sum. If you want to find out the sum of all the elements of the array, you can put sum of Z. Z is a complex array. If you want to find out the sum of a complex array, then you can just put sum. Okay, sum of Z will be A. So you can just type A. Since I've already executed this program, I can just type A. So what is A? A will be my sum of all the elements. So how can I sum all the elements of this? 2 plus 1, 3, 3 plus 3, 6, 6 plus 4, 10. So what is the real part sum? The real part sum will be 10. What is the imaginary part sum? The imaginary part sum will be 2 plus 2, 4, 4 plus 7, 11, 11 plus 7, 18. Okay, so 18 will be my imaginary part. So 10 plus 18i, that will be my summation of all the elements of the array set. Okay, I hope this is clear. Okay, now this, since Z is a complex array, I can find the complex conjugate. How can I find the conjugate? Okay, if I want to find the conjugate, okay, I will tell you another example for complex conjugate. So this is another example. I have created my A as 1 colon 10. What do you mean by 1 colon 10? 1 is the initial value, 10 is the final value, and what is the increment? Increment will be 1, isn't it? 1 is the initial value, so 1, 2, 3 up to 10. This will be my array A. What will be my array B? Again 1, 2, 3 up to 10. I have declared two arrays A and B. Now my set equal to complex of AB. What is A? A will be my real part. B will be my imaginary part, isn't it? Now sum of Z. If I find sum of Z, what will be my result? Sum of all the elements of this. Because Z is an array. isn't it? Z will be an array because A is an array, B is an array. So Z will be an array. So sum of Z will be giving you the sum of all the elements of the array. So A will be my sum. Okay. Now, if you want to find the conjugate of the array sets, because Z is the complex array. Z is a complex array. So if you want to find the conjugate, what do you mean by conjugate? Suppose the complex number is 3 plus 2y. What is the conjugate? 3 minus 2y will be the conjugate. And if the array is 2 plus 5y, 2 plus 5y, what will be my conjugate? 2 minus 5y will be my conjugate. I hope this is clear. So if the complex number is 3 plus 2y, the conjugate will be 3 minus 2y. If the complex number is 3 minus 2y, the complex conjugate will be 3 plus 2y, like that. Okay, so I can define my complex conjugate. This is just a variable. Okay, complex underscore conjugate. This is just a variable. You can define your own variables. Okay, so complex conjugate is just a variable. Conj, it's an inbuilt function to find out the conjugate of complex number. So in order to find the conjugate of a complex number, you can use the inbuilt function conj. And this is the complex underscore conjugate. This is just a variable name. So conj is a complex. To find out the complex conjugate, you can use conj. I hope this is clear. Let me run this particular program. So when I run this program, I will be getting Z value. I will be getting my A value. Okay. So if I want to display my Z, okay, what is my Z? Z will be this. See, Z will be this. What is the first element? 1 plus 1i. Second element 2 plus 2i. Third element 3 plus 3i. Fourth element 4 plus 4i, like that up to 10 plus 10i. Okay, that will be my complex array. Now, if you want to find out the sum, what is the sum variable? A is the sum. Okay, just type A. A is the sum. Sum of the real plus sum of the imaginary. So 55 plus, this is the real part, this is the imaginary part. Now, you can find out the complex conjugate. Just type this variable in the command window. You can just get the complex conjugate. So what is the conjugate of this particular array? You can define. So here 6 minus 6i, 1 minus 1i, 2 minus 2i, 3 minus 3i, 4 minus 4i, 5 minus 5i, 6 minus 6i till 10 minus 10i. I hope this is clear. So this is the complex conjugate. To find the complex conjugate. Okay, I hope this is clear. Okay. Now let me take another example of showing you a matrix. Complex matrix. In the last previous example, we have seen an array of complex numbers. Now in this example, you will be seeing matrix of complex numbers. How can you create a matrix of complex number? Just put 1 plus j, 2 minus 2j. This is the first row. 1 plus j, 2 minus 2j will be the first row. Put a square bracket here. This is a matrix. Okay, then after that you put a semicolon because this will be the first row. So this is separated by a semicolon. The second row 3 plus 2j, 4 plus 3j. This is the second row. Okay. Now how can you find out? This is a matrix. C is a complex matrix. Okay. So let me run this. Let me tell you what is C. So you can find out C here. C is a matrix. The matrix form you can See this, C is a matrix. 1 plus 1i, 2 minus 2i, 3 plus 2i, 4 plus 3i. You can see this C is a matrix. This is the first row. This is the second row. Contains, it's a matrix. 1 plus j, 2 minus 2j, 3 plus 2j, 4 plus 3j. That is a matrix. Okay. Now, if I want to find out the sum of this matrix, sum of all the elements, what you need to, since this is a matrix, you need to find out sum of C. C is a matrix. So this S will be giving you only the sum of each column, isn't it? Because C is a matrix. So sum of C will give you the sum of each column element, isn't it? Sum of each column. So again, you need to take the sum. So 2 sum. Here you need to take the 2 sum, because again you need to take sum of S. Sum of S. Okay, that will give you the sum of all the elements of the matrix, since this is a matrix. Okay, not an array. Okay, now if you want to calculate the transpose, okay, the transpose of this particular C. What is C? C is a matrix of complex numbers. C is a matrix of complex numbers. Now, if you want to find out the transpose of C, just put C dot slash. So this is the transpose operator, as you have already seen in the first experiment. This is the transpose, taking the transpose operator. If you want to find the transpose of a complex matrix, if you want to find out the transpose, not a simple matrix, not a real matrix, this is a complex matrix. So you need to put dot this transpose operator. You need to put dot. Okay, so here you will be getting the transpose. I have defined it to a variable trans. Trans is just a variable name. Next, if you want to have the conjugate transpose, what do you mean by conjugate transpose? It will be taking the transpose of the matrix but in the conjugate form. But all the elements will be in the conjugate form of the original matrix. Once again, I repeat, if you want to find the transpose, you need to put dot, then transpose operator. If you want to find out the conjugate transpose, that means a transpose of the matrix plus the conjugate of the all the elements. Okay, then you put a simple transpose operator. A simple transpose operator will give you the conjugate transpose of a complex matrix. This one I am telling for a complex matrix, not a real matrix. For a real matrix, just see if C was a real matrix, then C, then transpose operator, the C slash, that will be C, not slash, this is a transpose operator, and that will be giving you the transpose, the normal transpose, isn't it? But since this C, now the C is a complex matrix. Okay, this C is a complex matrix. So C, this transpose operator will give you the conjugate transpose, not the normal transpose. And dot, this transpose operator will give you the unconjugate transpose. Unconjugate. That means it's a simple transpose, not taking the conjugate. Okay. Now let me explain this by running. Run this code. Now you get what is C. C is this. Okay. Now if you want to take the conjugate. Now if you want to take the conjugate. Now let me show C. This is my C, original matrix C. Now what is sum? Sum is actually S1. Okay. So you type S1. What is S1? S1 will be the sum of all the elements. See, 3 plus 1 plus 2 plus 4. The real part, 3 plus 1 plus 2 plus 4 will be 10. The imaginary part will be 2 plus 1 plus minus 2 plus 3. It will be 4. Okay, so this S1 will give you the sum of all the elements of the matrix. Next, transpose. How can you find out? C dot star. So this is the variable, trans is the variable. So this type trans. Okay, just press enter. Okay, this is the transpose. 1 plus 1i. So this first row, what was the first row of C? C's first row was 1 plus 1i, 2 minus 2i. This will become the column. 1 plus 1i and 2 minus 2i was the row, first row. This, while taking the transpose, this first row will become the first column. So now look, 1 plus 1i, 2 minus 2i will be the first column. This will be the second column. Okay. So that is the transpose, just taking the transpose. Now conjugate transpose. Now let me see what happens to the conjugate transpose. This is the conjugate transpose. See, every element, we are taking the conjugate of every element. So 1 plus 1i will become 1 minus 1i. 3 plus 2i will become 3 minus 2i. 4 plus 3i will become 4 minus 3i. 2 plus 2i will become 2. 2 minus 2i will become 2 plus 2i. This is the conjugate transpose. And here you can look, this is the transpose. Transpose of the original matrix. I hope this is clear. Okay.